Hey, everybody. We are back in the Tennessee Reveal Geometry. And doing lesson 4.4, which is compositions of transformations. Okay, so let's talk about what that is. A composition is basically a series of moves. It can be a translation and then a reflection. It can be a reflection and then a rotation. It can be, any series of those. It can be even three things. Let's say you rotate, reflect, and then translate. That's what a composition is, but it's never a dilation. Dilation is when you increase the size or decrease the size of a figure. Um, so I guess you could have that. But since we're talking about isometry here in this one, that's not going to be in this lesson. All right, glide reflection. We're talking about that, and I'm sure it's gonna. Yeah, here it is, right here. Okay, so when a transformation is applied to a figure and then another transformation is applied to its image, the result is called a composition of transformations. All right, now a glide reflection is a very specific type. Glide is like a translation. You're gliding it across the page, you're shifting it across the page, and then you're going to do a reflection after that. It can be any kind of reflection across the x-axis, y-axis, origin. It can be across a vertical line, horizontal line. It can be across the line y equals x, y equals negative x. It can be across anything. Okay, so that's what a glide reflection is. And then you got isometry. The composition of two or more isometries is an isometry. So that's what I meant by it can't be a dilation, at least not in this 4-4. Okay, so here it is, reflection, translation, or rotation. There we go. All right, so let's get into the example. Okay, here's an example of glide reflection, which means we're going to do a translation followed by a reflection. All right, so we got our triangle PQR, and this is it because there's no primes there. There's P, R, and Q. And the vertices, 1, 1, so it's right 1, up 1. Q is right 2, up 5. And R is right 4, up 2. Determine the coordinates of the vertices of the image after the translation along -4, 0, and the reflection in the x-axis. Okay, so these are not parentheses. These are what we call component form, because this is the direction of the vector. This negative means we're going left 4, and this 0 means we're not going up or down anything. So I see they did it for us. P to P prime is left 4. 1, 2, 3, 4. Q to Q prime is left 4. 1, 2, 3, 4. And R to R prime is left 4. 1, 2, 3, 4. Again, when this is a 0, you don't go up or down anything. All right. For you people who are visual, you can get your ordered pairs. And if you are someone who is a plug and chug, your cheat code is x minus 4, because again, we're moving left 4, and y. And you can put y plus 0 if that helps you, but there's no change in your y because we're not shifting it up or down anything. Okay, plug and chug people. I'm going to take this 1 and replace it the x. So 1 minus 4 is a -3, and the y does not change. Taking the x, which is 2, replacing it in. So substitution to -4 is -2, and I'm not going to change the y value 5. And replacing the 4 for the x. 4 minus 4 is 0, and I'm not going to change the y value, which is 2. All right, so the new P prime is left 3, up 1, and you can see we have that. Q is left 2, up 5, and you can see we have that. And R is over nothing, up 2. So that 0 means we don't shift left or right anything, and then up 2. Okay, so you visual people, you've got it, and you non-visual, just plug and chug people, we've got it. All right, step 3. We want to graph the P, Q, and R primes, a reflection across the x-axis. Now, if you remember, when you're flipping it across this x-axis, it is going to flip straight down, which means we're going to change the signs of the y value. Because if I go left and up, my y value is positive. But if I go left and down, I'm still going left, which means my x values don't change, but my y values will now be negative because I'm going down. All right. Let me pause my video for a second. I got a teacher standing in my door. Give me just a second. All right, sorry about that. Okay, let's see, where was I? All right, so it's going to change the y coordinate. Now remember, don't look back at the original. You've already done something to that. So you want to look back at these right here. The -3, 1, the -2, 5, and the 0, 2. Okay, so here they are. And we're going to change, again, the y value. Here's your cheat code. And listen, if you're a teacher, some students will think that that negative right there, means that you have to make it negative no matter what. But that is not what that means. That means you change the sign. If it's positive, you make it negative. And if it's negative, you make it positive. So if you're a teacher, watch out for that. All right, so I'm going to keep the -3 the same. But this 1 is going to change from positive to negative. All right, this -2 is going to stay the same. And this 5 is going to change from positive to negative. And again, the reason why is because, remember, we're going left and then down the coordinate plane. So 0 is going to stay the same. And this 2 is going to change from positive to negative. All right. So if you're a visual person, you have just taken this and you have flipped that sucker over like a pancake, and it's going to sit right about there across the x-axis. All right, if you need another problem, there's an extra example online. So let's go to the check. All right. Okay, looks like I'm doing, again, a glide reflection because they're taking the original, that's called your pre-image, and they're translating it along a vector 0, 4. That means we are not going left or right anything, but we are going up 4. And then we're going to reflect it across the y-axis. Okay, well, no problem. The only problem I got is, a lot of my students like to show the ordered pairs after the translation and before the reflection because they need to see what the numbers are so they'll know that it doesn't go back to this. Okay, so listen, I'm going to do this straight out. And then I'll tell you what, I'll do it in GeoGebra for my visual people. Let's see what's going on. Okay, so here goes. 0 means that I do not add or subtract anything from the first number. So 6 plus 0 is just going to stay as 6. Because this is a positive 4, I'm adding 4 to the y value. So 6 stays the same, and then 4, or -1 plus 4 will be a 3. So you'd be looking at 6, 3. All right, 10 stays the same. I'm going to add the 4 to the -2. So -2 plus 4 will be a 2. So it'd be 10, 2. All right, and 5 stays the same. Add the 4 to the -3. So -3 plus 4 is a 1. So it's going to be 5, 1. All right, so I'll tell you what, because I know a lot of you are visual people, and you might be a brand new teacher looking at this as well. So I'm going to graph the pre-image JKL, and yeah, we'll just go from there, okay? So you guys can see it. All right, so let's see. I need a dot at 6, -1. So let's write 6 down, 1. I need a dot at 10, -2. So it's right 10 down 2. And then I need a dot at 5, -3. So it's going to be right 5 down 3. And don't forget to go back to your original. Okay, so you guys, this is the original, the pre-image triangle. I guess they use JKL, and I've got ABC. So tell you what, if you want to change that so you are not confused, not a bad idea. So that's your J, A, and L. All right, so I don't want anybody to be confused by that. All right, so there's JKL. All right, so remember, we are doing a vector, right or left, nothing, up 4. So I'm going to go over here to where my transformations are. Translate by vector. I'm going to click on the figure that I want to translate. And I remember I want to go up 4. So just click anywhere you want. Click down here. So let's click down here so I'm out of the way. And I'm going to go up 1, 2, 3, 4. Trying to get it straight on there. There we go. Oh, I guess it won't let me click. That's interesting. Won't let me click on an axis. Did not know that. All right, so let's back up. All right, so let's do this again. Translate by vector. Let me go a little bit further. Up 1, 2. Oh my goodness. I love technology. Undo, undo, undo. Okay, let's try this again. Translate by vector. Click on it. There we go. Good grief. 1, 2, 3, 4. Okay, boom. All right. So there we have the vector, your initial point, your terminal point. So I just moved it up 4. And you can count if you want to. 1, 2, 3, 4. J goes up 1, 2, 3, 4. K goes up 1, 2, 3, 4. All right, there you go. These are your ordered pairs that I just said. 6, 3, 10, 2, 5, 1. All right. Now we need to reflect that across the y-axis. So this J, which is 6, 3, reflecting across the y-axis. Well, you guys, this is your y-axis, which means I am flipping it over here. All right, visual people, let me move this out. So I'm going to take this figure and pancake it on this side. So I'm going to be equidistant from the y-axis. This L, which is 5 units away on the right side, will be 5 units away on the left side, which means that if I'm reflecting it across the y-axis, the x value changes. And I'm sure, nope, they don't have that. All right, I thought maybe they would have the cheat code, but they don't. So reflecting across the y-axis changes the x value. All right, so this J, which is 6, 3, changes the x value across the y-axis. So it's going to be negative 6, 3. And if you're a visual person, I am going to show you that on GeoGebra. All right, the K, there it is. K prime is 10, 2. And then for reflect across the y-axis, that 10 is going to change to negative 10, 2. Negative 10, 2. Same thing for L. All right, there's my L prime. So that 5, 1 is going to be negative 5, 1. Negative 5, 1. All right, so listen, if you're a visual person, I'm going to show you this. I'm going to reflect this figure across the y-axis. I'm going to come back, reflect about a line. And since it's the y-axis, I do not have to draw that line. So I'm going to click reflect about a line, click on the figure, click on the y-axis, and voila. There it is, my visual people. Same distance away. So L was 5 on the right of the y-axis. L prime is going to be 5 on the left. Same thing for J. J was 6 away on the right. J prime, or in fact, this double prime is going to be 6 away on the left. Same thing for K. Okay, let's move on. Example number 2. All right, that's what we got here. Compositions of isometries. We got our original triangle ABC. Graph a rotation of 180 and then translate. Okay. Well, a rotation around 180 about the origin is, oh, okay, it doesn't tell me, so it's going to be counterclockwise. That means you're going to do 1, 2. So after you rotate, it's going to sit somewhere in quadrant 1. So we're going to go to the left. 1, 2, because remember, 1 is 90, 2 is 180. So 1, 2. So it's going to sit somewhere right there. And if you're a cheat code person, all you're going to do is change the sign of X, change the sign of Y. And think about this for a second. That makes sense, right? Because all these order pairs are in quadrant 3, which means I went left and down. So left is negative for your X value, down is negative for your Y value. And if I'm going to end up somewhere in quadrant 1, it means that I'm going to have positive numbers. So here's your cheat code, and my visual people already know it's going to be right there. So the negative 6 becomes a positive 6, and the negative 2, a positive 2. Change that negative 5 to positive 5, and that negative 5 to positive 5. Negative 2 becomes positive 2, and -1 becomes +1. All right, so you're sitting right there in quadrant 1. All right, but now we got to do a translation. And here's your component form. This -2 means we are shifting left 2. The +4 means we are going up 4. So each one of these is going to go, and remember, we're right here, left 2, up 4. Ha! All right, so we're right here. We're going to go left 2, up 4. So it's going to be somewhere, I don't know, right in here maybe. All right. Now, that means that we are plugging and chugging. Do not go back to your original. That's what a lot of students are going to want to do. If you're a teacher, you guys watch this. We have to go off the prime. So I'm going to replace that 6 into the x, 6 minus, oh, okay, my bad. They have us to go ahead and give those again. So, sorry, 6, 2, 5, 5, and then 2, 1. Okay, so I'm going to replace that 6. 6 minus 2 is 4. Replace the 2 for the y. 2 plus 4 is 6. Replace the 5 for the x. 5 minus 2 is 3. And then 5 plus 4 is 9. Replace the 2 for the x. 2 minus 2 is 0. And replace the 1 for the y. 1 plus 4 is 5. All right, looks like we are done with, excuse me, example, whatever this was, example 2. All right, we are ready for the check. Let's see here. We have a segment. That's interesting. Segment whose endpoints are -7, 1 and -3, 2 for CD. We want to graph it, and looks like it's going to be somewhere, I don't know, around here, because that's where they've got the coordinate plane. Image after reflection across the x-axis and rotate 90 about the origin. Interesting. Okay. Well, you guys know me. I'm going to go straight to GeoGebra. So let me get out of all of this. Go back to my original. All right, let's graph this sucker. All right, so C is at -7, 1, and D is at -3, 2. All right, let's do that. And it's a segment, so I'm going to need 2 points. All right, -7, 1 is going to be left 7, up 1. And I'll change that to C in just a minute. And D is -3, 2. It's going to be left 3 and up 2. All right, so let's change this to a C for my visual people, and we'll change this to a D for my visual people. All right, now we need a segment. So third tool, second one down is segment, and it doesn't matter which one you click on first. There we go. Click on C to D. Remember, it does give us the length of this. So if you were to want to find the distance, there's a quick way to do it. All right, so we got to reflect across the x-axis, which means I'm reflecting across this line. So it's going to change to down here. It's going to be somewhere going this way. Because remember, C is 1 above. The new C will be 1 below. If D is 2 above, the new D will be 2 below. So it's going to look from here to here. All right, so we're going to reflect, and we're going to reflect this across a line. So I'm going to click on reflect across the line. I'm going to click on my figure. I'm going to click on the x-axis, and there it is. So C is 1 above, C prime is 1 below. D is 2 above, D prime is 2 below. All right, now we got to rotate 90 degrees about the origin. All right. Now, it doesn't say which way. It doesn't say clockwise or counterclockwise. So if it does not say, remember it is counterclockwise. That's your default. All right, so we're going to reflect about the origin. Well, listen, that means I have to have a point. I have to have a point. No, rotate, my bad. I have to have a point of rotation. So I'm going to put a point, what I want to rotate around, and they say it's going to be the origin. So I'm going to put a point right there. So this is my point of rotation. So I'm taking this figure and rotating it. So it's going to be probably 90 degrees. It's going to be somewhere about here maybe, because 90 and 180 would put it over in quadrant 1. So it's going to be somewhere in quadrant 4 is what I would imagine. All right, so we are rotating about a point. I'm going to click on my figure. I'm going to click on my point, and I'm going to get a box. So 90 degrees. And if it doesn't say it's counterclockwise, that's your default, and hit OK. Ooh, let me back out of this so you guys can see. All right, there is our answer. All right, so we need to get these, I guess, order pairs or just graphing it. Okay, they just want the graph. All right, so you need to draw your pre-image and then your reflected image, and then finally your double prime image is going to sit right about there. All right, I'm going to leave that to you guys because it will not let me actually graph right here. All right, next up. Okay, let's turn the page. Turning to page 263. Looks like we got a bunch of stuff just to go through, words and whatnot. So composition of two reflections. Okay, so it looks like I'm taking P, reflecting it once across line K, and reflecting it another time across line L to get P double prime. Okay, so if I go one distance and then a second distance, that's going to be twice the distance. Okay, so basically it's just telling you a double reflection is going to be twice the distance of the pre-image. And that makes sense. All right, then we got the next one, reflections in intersecting lines. So it says the composition of two reflections in intersecting lines can be described by a rotation. Okay, well that makes sense. If I'm taking the figure and I'm reflecting and then reflecting again, I'm just doing double, which is a rotation. So two reflections across intersecting lines make a rotation, you guys. All right. Example number 3. Looks like it's been done for us, which is great. So they're taking triangle ABC and they're doing a reflection across line N and a reflection across line Q. And it looks like the original distance is 3/8, double that to get the double reflection. So 2 times 3/8 is 3/4. All right, now we've got, looks like a, I don't know, parallelogram maybe. I am reflecting across line N and then reflecting it across line Q. A double reflection is a rotation, and that's why A and B lead the way going this way after the double. All right, so 2 times 25 degrees would be 50 degrees rotation. And again, when they do not specify counterclockwise as your default, so you're going left. All right, oh, we got to check here. Okay, so reflecting the quad ABCD, line M, and then line N. Remember, it is twice the measure. So if the original is 4.2, we double that. 4.2 times 2, that's going to be 8.4. Just multiply times 2, everybody. All right, example number 4. Okay, what are we doing here? Triangle ABC and DEF are congruent. Okay, I don't know. We're going to have to figure that out. If so, what composition or transformations maps ABC to DEF? Okay. If you're a teacher, your students are going to struggle with this. They can follow directions. It's like taking a recipe out of a cookbook. They can follow the directions. However, if you are someone, and I have been in this situation, who has a mother or a grandmother who can just throw things together because they've done it for so long, and it tastes beautifully, it's like working backwards. They will struggle. Okay, so yes, we are going to try to figure out how to make triangle ABC sit on top of DEF. Because, I mean, they look to be about the same. This is 2 blocks from A to B, 2 blocks from E to D. This is 4 blocks from C to B. This is 4 blocks from E to F. So, yeah, they look congruent. The question is, can we make this ABC sit on top of EDF after a series of movements? And, yeah, the struggle can become real. All right, so looks like we have a little tip here. It's about the origin, which means it's either a reflection or it's a rotation. Well, I tell you right now, teacher, it's not a reflection. Because remember, if I take this triangle and reflect it across the x-axis just to get it, below the equator, so to speak, this C is going to be way down here, which is okay because so is F. The B is going to be one below the axis, and that's okay because E is one below. And the A is going to be one below, and that's okay because D is one below, but it's facing the wrong direction. My triangle will sit like this, and that's facing the wrong direction because I need A to be facing this direction, which means it's a rotation. So I'm going to rotate it, not 90 because that would give me 1/4 turn. I need it to sit over here in quadrant 4. So from 2 to 4, quadrant 2 to 4, it's a 2 reflection, which is a rotation of 180. So I need to rotate 180 degrees about the origin. So I guess they want me to have a degree mark. Okay, so 180. And I need a degree. Where's my degree? There it is. Boop. And that's going to be rotation. No, origin. All right. And okay, well, now I'm sitting here and I'm sitting in the right direction because remember, C swings all the way around. A will swing all the way around and B will swing all the way around. I just need to shift it over. So the question is how much do I shift? All right, so I know it's going to be a translation. I just need to figure out what the vector is. All right, well, I'm going to go to my handy dandy little visual here, and I'm going to do the triangle original ABC, and then I'll rotate to show you guys that I was correct, and then I'll figure out what the vector is going to be. All right, so let's see. A was at 1, 2, 3, 4, -4, 1. B was at, I think, -2, 1. Yes, -2, 1. And C is at -2, 1, 2, 3, 4, 5, -2, 5. Okay, so I'm going to show you guys. First off, this is not a reflection. So you visual people, if you were totally lost with me, I'm going to reflect it and I'm going to show you guys how it's wrong. See, it's not facing the same direction. I need this corner to be on the other side. So that's how I knew it was a rotation. But it's because I've been doing this for years and years and years. You get kind of, used to doing something and, it's like putting a recipe together. You don't need a recipe if you've done something for 30 years. My grandmother was 106 years old when she passed away. She could make a chocolate pie just like that and not even think about it. All right, so I'm going to rotate around a point, which means I have to have a point. Boom, there it is. All right, we're going to rotate around a point. I'm going to take this figure around this point. I'm going to do 180. Get back here. 180 counterclockwise. All right. So there's my figure. See, now it's facing the correct direction. But now the question is how much do I need to shift it? All right, so everything is one below like I needed it to be. It's sitting right there. All right, so I need to figure out where E is. And right now I'm at over 2, down 1. This one is over 1, 2, 3, 4, 5, down 1. Well, how do I go from a 2 to a 5? How do I go from a 2 to a 5? Well, I'm going to add 3. So my component form is going to be right 3. But I'm not going to go up or down anything, so it's going to be a 0. So I need component form. Where's my component form? Component form. Component form. There it is. So it's going to be moving right 3, up or down, nothing. Come on, computer. Really? There we go. All right. Component form. Alrighty, so what are they wanting here? So I guess they're asking me, is it congruent to? And of course, yeah, it is. All right, so if you are visual, here it goes. I'm going to translate this sucker by vector. So translate by vector, click on the figure. I need to have a initial point. I need to have a terminal point over 3, and it should be sitting on 5, -1. All right. Good deal. Moving on. Oh, that's the last one. All right, that's it. All right, you guys, practice is coming up. That is on you. Ask me questions. Ask your teacher questions. We love questions, especially when it makes us think. All right, good luck, you guys. Talk to you later.